We will now learn to use the sample sphere cone function. This function is very useful when we want to randomize vectors around the volume of a sphere. Let's create a practical example to show this in a much graphical way. Same as last exercise, I will create a geometry node. Inside, I will create an attribute wrangler. And make sure to run over detail. Again, I will create 100 points, this time on the origin of the grid. So I will create my for loop. I will create my variable I with a value of 0, followed by a semicolon, and then my condition. So the for loop will run as long as I is less than 100, semicolon. And then every iteration of the loop, I will increase the value of my variable by 1. So type I++, close parentheses, open curly brackets, and close curly brackets. Now type add point, open parentheses. We want to add the points to this geometry. So type 0, comma, and then set. We will create the points in 0, 0, 0, and semicolon. Now type Control Enter to evaluate. And let's see if we have a typo here. Yeah, we forgot a parenthesis. And click on Display Point Numbers just to see that the points are created here. We will now create a line and copy this line to each of the points we just created with a copy to points node. So connect the line to the first input of the node and the points to the second input. And here we have our lines. Of course, the lines right now are all in the same position. It will appear to be just one. One thing I will do is rotate the line so it faces the Z axis. So I'm going to rotate it by 90 degrees. And now I will define a normal for these points to orient these lines that we just copied. So I'm going to create a point wrangler. And I will define my normal. So type v at n equals set to, let's say, 0, 0.5, 0.5, and close parentheses, semicolon, and evaluate. So by defining the normal here on our points, we're also defining the orientation of the lines. Now, a quick parenthesis, you may have noticed that I usually use the set function to create a vector. You can also set a vector with the curly brackets, for example, 0, 1, 0. And close the curly brackets. The reason why I don't usually use this technique is if I somehow want to change one of these values by a variable or by a channel. For example, let's try adding a variable or even an attribute. And try to evaluate this. You will notice this is erroring out. Whereas if I use a set function, it will usually shouldn't have a problem. So here it's working. So that said, I will continue using the set function to create my vectors. And let's now create the sample sphere cone function to randomize the orientation of these lines. So let's bring this down. Actually, for now, I'm going to comment this out. So I'm going to type // to comment this out and ignore this part of the code. And I'm going to create a new vector variable. So type vector, and I will call it new n for new normal. And this will be set with my sample sphere cone function. First of all, it will expect a vector or the direction in which the cone will be created. So for now, let's point it upward in 0, 1, 0. Then it will expect an angle. And for now, we will create a channel called angle. Just make sure that before we continue, let's convert whatever comes from this channel to radians using the radians function. So just make sure to close your parentheses. And lastly, the function will expect a random number. And this we can generate with the ptnum attribute. So let's type rand, open parentheses, and type at ptnum, close parentheses again, and semicolon. Now let's evaluate by pressing Ctrl Enter. And right now, nothing is really changing because we still need to assign this new variable to the normal attribute. So let's create our channel by clicking here on this button to the right. Let's change the angle to 180. And now let's assign our new n variable to our normal attribute. So type v at n equals new n and semicolon. So now notice how each of the lines is pointing in a different direction inside a sphere volume. And to notice this better, let me also add this variable to the p-scale of the points to scale these lines based on the result of this generated vector. So let's type below this assignment v at p-scale equals new n, or actually the length of this vector. So type length, open parentheses, then type new n, close parentheses, and semicolon. So now let's press Ctrl Enter. And the length function will return exactly that, how long is the vector that we just generated up here, and assign this to the p-scale of each point. So notice how some of these lines are bigger than others. And also, of course, they are oriented in different directions based on the cone that's been generated with this angle. So remember, right now we're pointing this angle upward with this vector, and whatever value we're inputting through this channel, we're converting to radians because this function is expecting radians. And then by adding a random number, we create different values each time. And this function will be very useful to help us create any kind of vectors with a random orientation. Just one final note before we move on. I noticed that I typed v for the p-scale attribute, generating a vector value, and in reality it should be an f, since the p-scale attribute is usually a float value, or it should be a float value. So you can also replace this part of the code, and now we can move on.